Yeah, so I'm just going over the emissions testing for the MOT, and I was really interested. I've got myself a gas tester. I'm going to do some more videos on this. I've got Gunson's gas tester and a Hawk gas tester. But this is for the emissions for petrol engines. This is not for diesels at the moment. I don't know much about diesel, but this in the Gunson's manual we have this chart that just shows you. I thought it would be really useful to put a video on because I didn't know nothing about it, and I just wanted to show what the emissions is all about on the petrol engine and why they're doing it. So along the bottom axis we got the fuel to air ratio, which they've gone from 11 to 1. So this is air to fuel, so 11 parts air to 1 part fuel, 12 parts air to 1 part fuel, etc, etc, 14, and then up to 17 to 1. So there's quite they're giving you a good range of things along the bottom. And then you've got the percentages of gas which is being created by the engine, by the combustion in the engine. So let's just first of all, so basically let's start with the stoichiometric ratio. So the stoichiometric ratio is 14.7 to 1, and that is what every petrol engine on the planet, all these injection systems, everything is built to achieve that ratio, 14.7. So on a petrol engine, so that line, that's what you're looking for when your engine's running, 14.7. So basically all the other gases that are produced, converted, the ratios are as stated on this little chart. So it goes as, let's say, so let's say for example, let's just quickly look on the weaker side of the chart because it's easier. But if your mixture ratio is, say, going above 14.7, say to 17.1, you can see the oxygen is going up, and that's because there's not enough fuel to complete the oxygen isn't required, basically. So you got more oxygen than you need. It is obvious, really, isn't it? More oxygen that you need, and then it's not really exponential. That looks to me like it's almost a linear curve going along like this. But you can also see that as the mixture gets leaner, also the carbon dioxide production also goes down. But that is because you're not burning as much fuel, and there's not enough. The mixture is weak. When you get to 14.7, that's the perfect balance between so you get the maximum carbon dioxide, the minimum oxygen, and the minimum carbon monoxide. So that's what you want. You're just getting carbon monoxide, and I think you're obviously getting some other gases, but this is about the CO2, the carbon dioxide, the carbon monoxide. So then what it also says there is and it shows basically also what I was reading as well is that carbon monoxide obviously is a colourless, odourless gas that's produced as part is an unwanted side production of combustion. So you can if your fuel ratio is correct, you shouldn't get carbon monoxide. So as the air to fuel ratio gets richer, that means there's too much fuel now. So then you've got carbon monoxide because there's not enough oxygen to produce the carbon dioxide. It's one. Well, I don't know about the complex chemistry of it, but is carbon monoxide, so that's 1 part carbon, 1 part oxygen molecule probably. Carbon dioxide is 1 part carbon and then 2 parts oxygen, so you got more oxygen in the carbon dioxide than in the carbon monoxide. So that obviously, that again is going almost linearly up, and then the carbon dioxide is going down because there's not enough oxygen to produce the correct. So if you look at that as well, the maximum production of carbon dioxide is, it seems to me it's like 14%. So so basically then the bit that they've highlighted is what you should be aiming for. So they don't seem to be aiming for 14.7. They're doing it on the rich side. I mean, presumably, if you have it too weak, you lose power. So they put it on the rich side. So here we've got in the highlighted zone, we've got the idle CO setting ranges for modern vehicles. So to me, that looks like about 13.2, maybe 13.3 to 14.5, something like that. So anywhere in that band is what they're aiming for. So for example, if you got 13.1, you got 3% carbon monoxide and about 13% carbon dioxide. If you, I think I've seen it somewhere else, but I think carbon monoxide is supposed to be within 3%. So if you anything richer than 13.1, then it's no good. It's producing too much carbon monoxide. Basically, just going around pumping out fuel into the air. So that's obviously, I mean, and bad gases, incomplete, unclean, poisonous gas because there's not enough oxygen. It's too rich. And then the band here is this one where I just highlighted in purple. So a typical recommended setting for a particular car, the width of the band shows the upper and lower limits. So it looks to me like it's about 13.9 to 14.2, something like that. So you're getting, say it's 14.1, you're getting about 2% carbon monoxide. Yeah, 13.5% carbon dioxide. I don't know the exact limitations. I'm going to do another video, but this is just this would just say that anyone could understand basically what they're looking for, because it's not very clear anywhere. Not many people probably know anymore anyway, because basically you've got a fuel injection car, the computer and the fuel injection and engine management system, they're doing the timing. The timing is automatic and everything, so no one ever has to check. No one ever, well, apart from maybe, I mean, the guys at the MIT know when they do the test, but the normal person doesn't really understand what they're looking for. So basically, you're looking for 14.7, and you get, that would be 0 carbon monoxide, 0 oxygen, and 14% carbon dioxide. So it's really saying allowable is that band within there. So that's about maximum 13.5% carbon dioxide and about 3% carbon monoxide. So if you're doing these tests and you get massive carbon monoxide, you obviously got a problem. Anything more than say 3%, and you're in trouble. And then if you're getting a very low carbon dioxide reading as well, obviously that's going down. That's gonna show you've got a problem as well. So, but it's basically, there's only one chart, obviously, isn't there? It's just so confusing when you get these testers and stuff, and it doesn't really tell you. So for every car, for any car, you're looking for 14.7.